Let's move on to the product rule for probabilities. It says, suppose that 2 cards are drawn without replacement. So without replacement means if you're dealt the king of spades for the first card, it is not put back into the deck of cards. So think about now there's one less card in the deck and one less king in the deck, one less spade in the deck, etc. Okay, so you have to reconsider after that first card is drawn what remains in the deck when you're going to be doing these problems. So without replacement is key here. Without returning, without replacement, you're not putting that card back. So again, it says, suppose 2 cards are drawn without replacement from a standard deck of playing cards. Let A be the event that an ace is drawn on the first draw, and B be the event that an ace is drawn on the second draw. Then the probability that an ace is drawn on the first and second draws, the probability of A and B. To find this, we need to realize that this is a conditional probability. So let's think about that. What's the probability of getting an ace for the first card? Well, when I go to buy the first card, so here I'm going to say the first ace, and here I'm going to say the second ace. Okay, the first ace, when I go to pick that first ace, there's 52 cards in the deck, and there's still 4 aces in the deck. But once I've drawn that ace, and I don't put that ace back, now there's only 51 cards in the deck, and because I already drew an ace, there's no longer 4 aces, there's 3 aces. The fundamental counting principle says multiply those 2 events together, and you'll have the probability of getting an ace on the first card and an ace on the second card. Putting this in the calculator and having it simplify, I'm getting a total of 1 over 221. That would be the simplified version of the answer. And so let's see what they did on this one. They broke it into a tree, and I think this is way more complicated to do it this way. So let's look at it. It says, what's the probability that the first card was an ace and that the second card was an ace? So they say, look, 4 out of the 52 cards are an ace, 48 out of the 52 are not an ace. We don't care about this because we know that the first card was an ace. Okay, we want the second card to be an ace as well. So that's how they're getting their 4 out of 52 and 3 over 51. I'm not going to lie, though, their tree is so much more complicated than it needs to be. Using that notation in the book is so much more complicated than it needed to be. All you have to do is recalculate the probability of the second card, given that the first card was drawn. So just think, normally an ace would be 4 out of 52, but now that card is gone, I need to reconsider the deck and what I have to get my probability for the second one. That's what it's saying to do in this formula right here, even though it looks confusing. It says, do your first card, probability of getting an ace, like you would no matter what. You just find the normal one. But then the second one, it's saying, look, you have to realize something's already happened. You've been given that first card was an ace. Recalculate it. And then multiply those 2 numbers together.